All right, this is the second day of 2-9 larger systems. And today we're going to do the substitution method. So we did elimination with the systems of 3, x, y, and z. And today is substitution. The way we do it with 3 is very similar to the way you do it with 2. So as far as methods go, it's going to feel very much like doing regular substitution, just again, more of it. Just like when elimination, there's more of it. A couple things to remind you guys about: that when you do a system of 3, your solution is an ordered triple, so an x, y, z coordinate. So just make sure that you don't stop at x, or just don't stop at x, y, but get all the 3 parts of that. So you got to work your way backwards through the problem once you get the first variable solved for. So a couple things about substitution, just to remember how we did it when we did systems of 2. You solve one equation for one variable, and then you plug it in or replace that in the other equation. The difference here is we're going to solve one equation for one variable, but you're going to have to replace it in the 2 other equations. So again, it just creates kind of more work, but not necessarily a more difficult problem. And then once we get one variable solved, again, we'll back our way up to the problem and find the other 2. And that's essentially it. So just like yesterday, we're just going to do a couple examples, keep it kind of short. Well, short as you can with these. And then when you guys get done with this, you'll have a quiz. I don't have the bubble, or the graphic organizer today, but I think you can probably follow along without that. I think that's actually a better organizer for elimination than it is for substitution. So first thing to do is write down your system. So take a second to write the system down. To do that, you can just pause the video and then restart it. So I'm going to keep talking, essentially. Just pause it if you need to. Write it down. So I'm giving you guys the instruction to start now. As you guys are looking at the 3 equations, again, I think like same with elimination, one of them sort of jumps out as the one I will start with. I definitely like the blue. It's got all the basic variables, just 1x, 1y, 1z. And as far as which one I'd solve for, I'd probably go for x or y. I'm going to say let's go ahead and solve for x. So we're going to do that. So we're taking the blue equation, solving it for x. So move the y and the z over, and you're ready to go. Now where the arrows are pointing is where the substitution happens. So once you solve that first equation for x, the idea would be to plug it into the other equation. In this case, both of the other equations. So there's my red and my green equations. What's going in that spot would be the substitution for x. So now we're going to go ahead and sub in. What we're going to try to do, again, just like yesterday, is get it down to a system of 2, reorganize that as another system, and then continue on. There's going to be a bit of cleanup here, so you got to distribute the 2 in, you got to eliminate the parentheses, get all your like terms combined, so that'll take a little bit of time. So let's start out with the distributing part. So distribute it in, drop that set of parentheses off, combine y's, combine z's, and now we're down to a system of 2. The next thing to do is reorganize our system. So we want to get those 2 put together in their own system. Now this is the point where you guys can decide to switch away from substitution if you like. So we're really only saying start the system with substitution. But when you get to the systems of 2, like the midway through the problem, feel free to do whatever. I'm actually going to switch over to elimination now because I think it just works better for what I have. And when I look at that set of equations, what I think of elimination is probably the z's, because you got a positive and negative, which is already got the plus minus going on. You are going to have to change both equations. So I'm going to multiply the top one by 2 and the bottom one by 3. That's going to give me a plus minus 6z going on, and that's going to get rid of my z's. So let's get those multiplications done. Distribute the 2 and distribute the 3, and then we're going to add down in columns. Now remember, at this point, try to get down to that single variable. The z's are going to drop. Again, that's what I wanted. I've got negative 28y equals negative 56, and divide by negative 28, and y is 2. So at this point, I have a third of my solution, right? I only got the y value. Now we got to start back substituting our way through the problem. So I'm going to pick either this or this to plug my y value into. It doesn't really make any difference. I guess I'll go with the green one because the numbers are a little bit smaller. So in that spot goes my 2. And then I'll continue on and keep solving. So add the 12 to the other side. Divide by negative 2. Now I have 2/3 of my solution. Now I gotta go back to one of the original three. If it's me, I'm picking the blue equation, the first one, because that one, of course, has got the least going on. And also remember that when you're doing substitution originally, this equation is one that would be helpful. So what I'm gonna do is I'm gonna probably just take that exact equation, I'm gonna bring it down here and use it. That's one of the nice things about doing substitution is the one that you need to plug into last is the one you created first. So now what I can do is say, all right, let's figure out the x. Plug in my y, plug in my z. That's -5 plus 9, so I'm getting the x value of 4. Solution to my system. Okay? So, like elimination, there's, definitely a little more work going on. We do systems of 3. I'm not going to lie to you guys about that. It's definitely more work, but I don't think it's more complicated work. It's just more of it, right? Okay, we're going to try one more just to make sure we got it, and then we're going to switch to a verify or prove that a point is a solution to a system. And that's going to be it. Again, just like yesterday's notes, kind of keep it as short as we can. These problems got enough going on. We don't need to do a ton of them. All right, one more round of substitution. So again, pick your equation. We're going to go with the blue again. I like the blue because it's got a lone x and a lone z. This time we're going to go z, solve it for z, just to practice doing something other than always pick an x. So copy your system down, and then first thing to do is pick your equation, and we're going to solve the blue for z. So I solve it for z. Now again, the arrows are pointing to where the substitution is going to happen. So in place of those two z's goes my z, my new expression. So there's the substitution. So I got my red and my green, and in those two empty spots goes that. So sub it in, sub it in. Again, there's a round of cleanup here. Get rid of your parentheses, so distribute the negative in the red, distribute the 2 in the green. Get all your like terms put together, your x's, your y's in both. Now, it just so happens in this one, something unique happened. The x's and y's, the x's dropped, that was nice. The y's got down to basically a single y, and we solved for it. There's a step in between that I left out, which, let's just show you that quick. Those drop, this would be negative . And then wrap it up with that. Now again, back substitute my way through, right? So what I'm going to do is pick one of my two. Well, really, you don't have a choice, right? It's kind of nice about this one. You can't plug it in this value anywhere but over here. So I got to take that -1 because there's not 2. I'm just got, 1, just the red, and plug it in and solve for that. So this is kind of nice. This happened. It won't always happen, obviously. Sometimes you have to do like the first problem, just go through the whole batch of work. But at least here we got a little bit of a shortcut by getting that y = 1 right away. So I got 2/3 of a solution. Again, I got to go back up and pick one of the original ones. Now, what I was saying about substitution and doing this equation, the reason you do this one is not just for the original substitution, but by solving for that lone variable, then subbing into the other equations, you have actually purposely created the equation that you would plug the other numbers back into. So I would just always use this as my final step. Plug in my 2, plug in my -1. So I've got -2 plus 2 plus 3, so I got 3. Solution. So solving systems by substitution, pretty straightforward. I think it operates just like like you normally would with substitution. I just don't know if there's a big difference in work between this and elimination. So again, it might just be like personal preference. I like one over the other. I kind of like substitution almost a little bit better. With systems of 3, I feel like the elimination just has a little bit more going on. But again, personal preference, whatever you decide is fine. In the assignments, you're going to be asked to do specific things and just sort of stick to that. The last thing would be, verifying that coordinate is a solution to the system. And, we know how to do this from past experience, just plug it in, right? So I've got my system. I've got it laid out. I'm going to test this coordinate. To test that coordinate, I'm going to plug that coordinate in all 3 spots. And then just checking yes or no, do I get a true statement? So if we're checking it out, this would be 4 plus 2 is 6, plus 3 is 9. 9 equals 9. So far, so good. We got 8 minus 6 minus 3. So that would be 2 minus 3, which equals negative 1. Check, that one's good. 4 minus 10 plus 9. So that would be negative 6 plus 9 equals 3. Check. That's a yes. Along the way, when you're doing this, if you get a no, if the first one's a no, just stop. If the first one's a yes, okay, you got to do the second one. If the second one's a no, stop. If you get 2 yeses like I did, then of course you got to go to the third. If the third one was a no, it'd still be a no. Any one of them being no creates a no overall. But 3 yeses, that's definitely a solution. Okay, that's going to be it for the notes for the second day of Systems of 3 substitution.